In section 2, we're going to talk about adding, subtracting, and multiplying polynomials. So a couple important things when you are adding and subtracting polynomials is that you can only do it with like terms. And like terms are terms with the same variable or variables and exponents. So for example, x squared and 3x squared are like terms because they have the same variable x and exponent of 2. Whereas xy and xy squared are not like terms, because even though they have the same variables, x and y, they don't have the same exponents. So when we talk about combining like terms, we are adding or subtracting multiple like terms into one term. So that means adding polynomials is combining like terms by addition. And subtracting polynomials is combining like terms by subtraction. And you can have both of those in the same polynomial, so it doesn't have to be all addition or all subtraction. You can have some addition and some subtraction. But you're looking for like terms. Okay. So let's go ahead and look at some examples. So for our first example, we have 2s squared minus 3x plus 2 plus 4s squared plus 2x minus 7. So I'm going to go ahead and identify all of my like terms. I have 2s squared and 4s squared. I have a negative 3x and a 2x. And then lastly, my 2 and negative 7. And because I am adding, I can just go ahead and combine those like terms. So 2s squared plus 4s squared is going to be 6s squared. Negative 3x plus 2x is negative 1x or negative x. And then 2 plus negative 7 is negative 5. And that's going to be my most simplified answer. Okay. Next we have 4x to the fourth minus 6x cubed plus x squared minus 6 plus x cubed minus 5x squared plus 1. So I have 14x to the fourth. There is no other like term there. I have negative 6x cubed and x cubed. I have x squared and 5x squared. Then lastly, I have negative 6 and 1. So since 14x to the fourth doesn't have another like term, it stays 14x to the fourth. Negative 6x cubed plus x cubed is going to be negative 5x cubed. X squared plus negative 5x squared is negative 4x squared. And then negative 6 plus 1 is negative 5. So when you are adding polynomials, you can basically pretend those parentheses don't exist because you can just combine the terms as they appear. Next, we'll look at a couple subtracting examples where there is a slight difference. So for subtracting polynomials, you're actually subtracting the entire polynomial that appears after your subtraction sign. So I have 2a cubed minus 5a minus 7 minus a cubed minus 2a squared plus 3a minus 7. So what I do here is I go ahead and distribute my negative into my second set of parentheses because there's technically a -1 in front of this parenthesis that I'm going to distribute to all of my terms so I can think of it more of an addition problem. So it becomes minus a cubed plus 2a squared minus 3a plus 7. So now I can go ahead and identify my like terms. And I do always like to go in descending order when I'm identifying any like terms, just because it's a little bit easier. So I have 2a cubed minus a cubed, which is just going to give me a cubed. There is no other a squared term, so I'm just going to leave it as plus 2a squared. Negative 5a minus 3a is negative 8a. And then negative 7 plus 7 is 0. So my final answer is a cubed plus 2a squared minus 8a. My second example, I have 7x to the fourth minus 8x squared plus 8 plus x minus 9x to the fourth plus x squared minus 18. So again, I'm going to distribute that negative into my parentheses. So we have 7x to the fourth minus 8x squared plus x minus 9x to the fourth minus x squared plus 18. So then I go ahead and identify my like terms. So we have 7x to the fourth minus 9x to the fourth, so we get negative 2x to the fourth. Negative 8x squared minus x squared, which is negative 9x squared. And I don't have any like terms for my x, so it stays plus x. And I don't have any like terms for my 18, so it stays plus 18. So that is adding and subtracting polynomials, just combining like terms. So the next thing we have to talk about is multiplying polynomials. So when we are multiplying polynomials, we are basically just distributing into a set of parentheses like we did in Module 1 when we were trying to solve for x, and anytime we had to distribute into a set of parentheses first. So the first thing we're going to talk about is just to kind of recall when you're multiplying two monomials. So just kind of refresh, a monomial is an expression with one term. So polynomial means multiple terms, so two or more. Monomial means one term. So when that happens, I multiply numbers and then I multiply like variables. So 7y squared times negative 4y to the fifth, so parentheses indicate multiplication. I do 7 times negative 4, which is negative 28, and I do y squared times y to the fifth. Now, when I multiply with variables, I don't actually multiply the exponent. So if I'm doing y squared, which is y times y, times y to the fifth, which there are 5 y's when that happens, I'm basically just counting how many y's do I now have, and I end up with y to the 7th. So when I multiply variables, I actually add exponents. So it does not actually multiply, so y squared times y to the fifth is not y to the 10th. So my next example, negative a squared b cubed c times 10abc to the 12th. So that negative in front I treat as a -1. So -1 times 10 is -10. A squared times a is then going to become a cubed. B cubed times b becomes b to the 4th. And then c times c to the 12th becomes c to the 13th. So just remember, if there is no exponent written, it's a 1. So that's just reviewing a monomial times a monomial. Now we're going to talk about multiplying a monomial by a polynomial. And this is where we are going to distribute into parentheses. So we're going to use our distributive property. So 4x times 3x minus 2, I'm going to multiply my 4x to everything inside my parentheses. So 4x times 3x, I do 4 times 3, which is 12. I do x times x, which is going to give me x squared. Then I have 4 times negative 2, which is negative 8. And x has nothing to multiply with since there's no variable there, so it just stays x. So my final answer, 12x squared minus 8x. Then we have negative y times 4y squared plus 2y minus 3. So again, I'm just distributing that into my parentheses. So negative 1 times 4 gives me negative 4. Y times y squared is y cubed. Negative 1 times 2 is negative 2. Y times y is y squared. And then negative 1 times negative 3 gives me positive 3. And then the y has nothing to multiply with, so it stays y. And that's going to be my final answer. Next, we have multiplying two polynomials. So in this case, we're still going to distribute, but you want to distribute everything in the first set of the parentheses to everything in the second set of parentheses. So for example, 2p plus 3 times 4p plus 1, I'm going to take my 2p and I'm going to multiply it to everything in that second set. So 2 times 4 gives me 8. P times p is p squared, and then plus 2p times 1, which is just 2p. Now I have to take my 3 and multiply it to everything in my second set of parentheses. So 3 times 4p is going to be 12p, and then 3 times 1 is 3. Now after I distribute, so you distribute, so that's the first step. Then you're going to combine like terms. So unlike the previous two we talked about, a monomial times a monomial, since there's only one term, there's no like terms to distribute. And if you only distribute one term into a set of parentheses, when we did a monomial times a polynomial, there weren't any like terms there either. But if you're multiplying two polynomials, there is a chance for there to be like terms after you've distributed. So I have 2p and 12p that are going to combine. So I have 8p squared plus 14p plus 3. Next we have a squared plus 3a minus 4 times a plus 2. So I'm going to multiply a squared into my parentheses, so I get a cubed plus 2a squared. Next, I'm going to multiply 3a to both of them, and I get 3a squared plus 6a. And then lastly, I'm going to multiply negative 4 to both. So I get minus 4a and then minus 8. So when it comes to like terms, we have 2a squared and 3a squared. And I also have 6a and negative 4a. So I end up with a cubed plus 5a squared plus 2a minus 8. So last example for this is x squared minus 4x plus 3 times 2x cubed minus 4x squared minus 4x plus 2. Now, I'm not going to give you a lot of examples like this last one where you have 3 terms times 4 terms. The first two examples we did are more in line with something I might ask you to do, where you have 2 terms and 2 terms or 3 terms and 2 terms. But we're going to do one example just so you can see how it changes. So I'm going to distribute my x squared first to everything in my second set of parentheses. You're going to end up with 2x to the 5th minus 4x to the 4th minus 4x cubed plus 2x squared. Next, I'm going to multiply negative 4x to everything in my second set of parentheses. So I have minus 8x to the 4th plus 16x cubed plus 16x squared, and then minus 8x. Last one, I'm going to distribute 3 to everything in the second set of parentheses. So we have plus 6x cubed minus 12x squared minus 12x, and then plus 6. So there's a lot more like terms here. I have negative 4x to the 4th and negative 8x to the 4th, negative 4x cubed, 16x cubed, and then a 6x cubed. I have 2x squared, 16x squared, and negative 12x squared, and then negative 8x, and negative 12x. So that ends up being 2x to the 5th, so there's no like terms there. Negative 4x to the 4th minus 8x to the 4th is negative 12x to the 4th. Negative 4x cubed plus 16x cubed is 12x cubed, plus 6x cubed is going to give me 22x cubed. Then we have 2x squared plus 16x squared, which is 18x squared, minus 12x squared, which is going to give me 6x squared. And then negative 8x minus 12x is negative 20x. And then lastly, the plus 6. And I have my final answer. So like I said, I'm not going to give you a problem like that on an assignment or an assessment just because very time consuming, but you can expect to have to do something like the first 2 examples we did. All right, and the last thing we're going to talk about is a shortcut method. So it is very specific to when you're multiplying 2 binomials. So binomials are expressions with 2 terms. So if monomial means 1 term, binomial means 2 terms. Technically, a binomial is also a polynomial because it has 2 or more terms, but it is also known as a binomial. So there is a method called FOIL, just to kind of review. So the F stands for first, the O stands for outer, the I stands for inner, and then the L stands for last. So it basically tells you which terms to multiply. I don't use it a whole lot because I like to refer to it as distribute, which is basically what FOIL is telling you to do, is to distribute. So let's just do a couple examples. So I have 2x plus 5 times 3x minus 7. So my first, I'm going to do that with red. My first is my first terms, which are 2x and 3x. So that's going to give me 6x squared. Right? Outer is my my two numbers on the outside of each parentheses, which is 2x and negative 7, which is going to give me negative 14x. Inner means the two terms that are closest to each other, which is 5 and 3x, which is going to give me 15x. And then last is the last terms in your parentheses, which is 5 and negative 7, which is negative 35. And then I just combine like terms. So I have 6x squared plus x minus 35. All I did was distribute. It just has a shortcut call. So for next one, x minus 7 times x plus 5. First terms are x and x, so I get x squared. My outer, x and 5, so 5x. My inner, negative 7 and x, so negative 7x. And my last, negative 7 and 5, which is negative 35. So I get x squared minus 2x minus 35. Let me know if you have any questions about adding and subtracting polynomials or multiplying polynomials.